All right, well, thank you everybody for coming. Today we are going to be talking about XR, or more specifically, we're going to be talking about virtual reality, how to get started with virtual reality in Unity. This workshop, I mean, it's a relatively new tool set. Unity relatively recently released their XR toolkit. And this is a tool set that was designed to facilitate or accelerate a design and development process, both for augmented reality and virtual reality. Today, we're just going to focus on the virtual reality component, but know that Xrtk serves both VR and AR. So a little bit of background. Actually, I should clarify before we get going. I'm going to be working in Unity 2019.4. It says 2019.2. That's the minimum version requirement. If you are planning on following along, given that this is an interactive workshop, crack open either 2019.2, 3, or 4. We're going to use just the starter files to work together. But either way, stay in the 2019 range. So a little bit of background on myself. I'm the director of design. I'm one of the Unity developers at KairosXR. We're a development agency. We specialize in building out interactive 3D content, specifically for training and education. So we work across enterprise. We work from automotive, primarily AEC, quite a bit in healthcare as well. But like I said, core focus now is the AEC landscape, and building out solutions that can accelerate the comprehension process within the training and education space. So like I said, this is an interactive workshop. What project are we going to be working in? Well, this is one of our, we have a client project. We use a Snaps package for this environment. This is, we're taking a segment from one of these projects. We built out interaction, we built out locomotion, all using the Xrtk, making it such a strong example project, not to mention using the high definition render pipeline to increase graphical fidelity as well. So we'll crack that open, we'll take a look, take a peek inside. But in terms of the interactive workshop component, we'll be working in another example project. So the goals for today, well, we're gonna start with a core capability overview of what Xrtk is, what it's capable of doing. And then we're actually going to work together to set up Xrtk in the project. So hopefully by the end of this workshop, you'll be able to go back to your hackathon team and you'll be able to, if you're focusing on a VR project, you'll be able to use the Xrtk for that project. You'll find that Xrtk has taken what was once either hundreds of lines of code, maybe even thousands of lines of code, and turned setting up interaction and locomotion into just a few clicks, which is why this is such a breakthrough tool set. And you'll see that. Xrtk is a few core pieces of functionality. And yes, we're going to set this up, but we're also going to explore some of the additional features that it has to offer. And by the way, Cody mentioned this, but if you have any questions along the way, given that this is supposed to be an interactive workshop, go ahead and drop those in the chat or drop those in the QA at the bottom. And I'll get to those as soon as possible. All right, so like I said, if you're going to follow along, I will be working in 2019.4. You can open up a new Unity project, and rather than defaulting to 3D, go ahead and hit this 3D with extras, and that's going to give you a nice little starter, lightweight starter package for us to play around with. Then when you're ready, go ahead and import the Xrtk package from the package manager. And while you're doing that, while you're opening up Unity, let's start from the basics. Let's talk about why. First of all, why we're using Unity in this case. We see Unity used in a professional context, from AR to VR, across architecture, across construction as well. And really, fundamentally, Unity is a design tool. It's the benefits of real-time visualization not only accelerate the design process and also democratize the design process, reaching remote teams as well. But oftentimes it is used very much in the development process as well, and the project planning and management. So on the left here, we have Shop, the Shop architects, the architecture firm, using Unity and virtual reality to visualize a few of their projects. Excuse me, I said virtual reality, augmented reality, to build some of the CAD architecture in the context of the real environment. Or we have an example of virtual reality being used for design in the center here. As you can see, bringing in different stakeholders and incorporating those stakeholders into the design process. Of course, the benefits of that, as I mentioned, more voices. So not only do you have technologies coming out of Unity that can reach remote teams and incorporate them into the design process, it benefits the local teams as well, again, by bringing in different areas of subject matter expertise. So all of this brings us to Xrtk. That is just a quick overview of why Unity is so helpful, because Unity is the platform that supports virtual reality and augmented reality as well. But with that said, where does Xrtk fall into this? Well, how do you move around in virtual reality? How do you grab objects in virtual reality? And that's why the interaction toolkit is so important. Prior to this, there are a few different ways that we can incorporate interaction and locomotion into our VR and our AR projects as well. A little history lesson. When I first got into XR development and design, I very much believed that we needed to be able to build everything from the ground up, and that would be the most flexible, that would be the most extensible. It took me a little while to realize that we should be using the existing interaction tools and the existing locomotion tools as well. A few examples: VRTK, Steam VR, Oculus is a great interaction tool set as well. OpenVR, these are all these SDKs, and they're all frameworks that do a lot of the legwork when it comes to building out interaction and locomotion. But with that said, even though they're taking care of quite a bit of the legwork, it still took a considerable amount of dev hours to build out basic interactions and basic locomotion. And Unity took issue with this, which is why they came up with Xrtk. Again, consistent with their motto of build once, deploy everywhere, we now have a tool set that works across different platforms that really only requires a few clicks to build in interaction, build in locomotion. So the problem solved. Again, these tool sets, as phenomenal as they are, they're still complicated to set up and configure. And they still had a significant development cycle as well. By the way, if you're using the Oculus toolset in this case, or the Oculus framework, you can't deploy onto devices using Steam in that case. So all of a sudden you have this cross-platform issue, and Xrtk ameliorates everything. So again, it's easy to download, set up, simple teleportation, simple customizable grab interactions. And by the way, once you grab an object, if you want to precisely place it somewhere, you can do so using their socket system. And this extends to user interfaces as well. How do you build a UI menu using virtual reality, for instance? Well, they have a new system that's even simpler than the old. So let's go ahead and get started. So like I said, we're going to take a look at an example project. Here's one of our clients' projects using, again, the Snaps package as the environment. Given that we did need to swap out environments. And we can see the demo on the right here, but we're going to do a little live demo here. So I'll go ahead and share my screen, do a new share. All right, make sure we'll maximize on play. And of course, here's the Unity project. I'm going to demo really quickly, and then we'll take a peek at the hierarchy. I'm going to wait for it to boot up. All right. So again, we have our UI menu, and then we have our site. In the spirit of starting with why Unity first, again, you can see that Unity, it's the age-old debate is Unity versus Unreal. Should we use Unity or should we use Unreal? And as you can see with a high definition render pipeline, you can produce some really, really compelling graphics. Here I am, this is a teleportation system. I can go around the project if I want to get a better vantage point. I can snap to a higher vantage point and take a look at the rest of the project. Well, let's say we wanted to grab an object. Again, we have this little interactable cube. I reach down, I can grab the cube. Now, you may be wondering, why do I have this ball here? Again, that's just a placeholder. We don't have hands. But if we have this ball, it acts as a visual representation of my hand. So again, this is the project that everybody here by the end will be able to build. But we're not going to start there because we're also not going to work with HTRP. We're going to start with an example project. So I'll go ahead, I'll close that. I'm going to do another share now. Share my whole screen. Let's go ahead, we'll shut that down, and we're going to open up a new project. I'm using Unity Hub to open this up. Like I said, we're going to open up a project in 2019.4. Let's go ahead and call it Xrtk live demo. And then from there, open up with 3D with extras. Of course, now we're going to let Unity think a little bit. It's going to take a second to open up, just initialize the library. And in the meantime, if anybody has any jokes, because jokes are always a helpful way to pass the waiting time, instead of creating a bunch of dead space, feel free to drop them into the Q&A and I will read them. And by the way, I will give you credit as well. All right, so we're importing a few of the packages here, and of course this is recorded, so this bit can be edited out. Go ahead and cut this section out. And while we're waiting, let's go ahead and we'll revisit the slide. So what are we going to do to set up Xrtk? We're just bringing in the packages in this case. In order to do so, again, you're going to open up a new Unity project, and then you're going to import the Xrtk package. And then there are two more steps to get VR into your project. You'll install the Oculus SDK. And then on top of that, you will drag the XR rig into your scene. And all you have to do is hit play. After that, everything is taken care of. And if you've been working in virtual reality in Unity for a while, you'll know that typically there are more steps to implement VR in your project. That's really it. I mean, this demonstrates 4 steps. It's really just 3 steps, however. And you'll see just that. So let's go ahead and take a look at our project, see if it is opened up. And it has. All right. So now we are in the 3D with extras. Let's go ahead and get started. So this extras project actually comes out with this post-processing volume. As a reminder for navigation, if you're using a mouse, go ahead and hit the right mouse button, right click, and you can use WASD to navigate around the scene. That's how I'm moving around so gracefully. And this extras project has a post-processing volume, so it has post-processing effects. And it's a basic little scene. Also see that we have a camera, we have a directional light. We can modify the directional light if we like. Blue, we don't need to do that though. And then all of our example assets are in this example asset folder. Cool, so let's go ahead and get started. First of all, let's kill the camera. And then let's go to our package manager. Make sure preview is on because it's still in preview. And then type toolkit in the search. Awesome. Let's go ahead and install that. And last time around, this took about 5 to 10 seconds, so I don't think we're going to be stuck in too much of a waiting time here. And of course, because it's a live session, it's going to take a little longer. All right, here we go. So now Xrtk is, if you check the packages, it's in our project. That's all we had to do to get in our project. So let's go ahead and shut down Package Manager. But now that Xrtk is in our project, now what do we do? How do we get VR? Well, we can either set up the scene or we can set up the plugin. Remember, there's the second step. So let's go ahead and set up the plugin. So let's go into Project Settings and then go to XR Plugin Management at the very bottom. The XR Plugin Management is critical to manage all of the, well, by the name, all of the plugins. So if we had one of the Windows headsets, if we're using Oculus, for instance, each one of these different types of headset platforms requires a different plugin. And here is just one area to manage every single plugin. So in this case, say we are building out Magic Leap. Xrtk does provide support for Magic Leap as well. So we have the Magic Leap plugin. Oculus, Windows Mixed Reality. So we're going to go ahead and we'll install the Oculus plugin because if you look at the camera, I am using an Oculus Rift S. So we'll go ahead and we'll install Oculus. Now we are good to go. Looks like we have a little bit of a bug in loading this GUI. That's all right. You can take my word for it. We are good to go. And let's double check that. Yes. So we close that down, open back up, and we see that Oculus is installed. And we can see it at the bottom here. Here's the plugin. Okay, but how do we get VR? If we were to hit play, we're not going to get any kind of VR activity, right? The reason being is because we deleted the camera. We don't have a camera in our scene. So let's go ahead and add an XR camera rig. If you right-click in the hierarchy, you'll notice this XR parameter. And then we have a bunch of XR goodies, we'll call them, that we can play around with. We have a bunch of prefabs that we can generate. And the reason why we have so many is pretty much relative to your workflow. We only care about room scale XR. If you wanted to use a stationary XR rig, for instance, if you're using Oculus Go, a 3DOF headset, rest in peace. If you're using a 3DOF headset, then you wouldn't need to be able to move around, or you wouldn't move around at all. It's only 3 degrees of freedom, so you use a stationary XR rig. In this case, you're using room scale XR because this is a 6DOF device. So let's go ahead and add that room scale XR rig. All right, now let's take a look. So you'll notice that this is just an empty game object with the XR rig attached to it, and this is the magic of Xrtk. Look how simple this hierarchy is. We have a camera offset just for positioning purposes, and then we have our camera. There's nothing really special about the camera except for the track pose driver, which keeps track of all of our pose information, the position, but also the rotation of the camera. And that information is based on the headset, by the way. It takes the rotation and the position in the virtual world and then applies it to our headset, and then vice versa. It's the communication system between the headset and the virtual world. And then we have our left hand and the right hand. If you look at the left hand, this is an example, we have the XR controller, we have the XR array interactor, line renderer, and then an XR interactor line visual. The only thing you need to care about here, out of the gate, is the XR controller. In fact, if you were building this from the ground up, just to get VR, you need to have an XR rig, the tracked pose on the camera, and then the XR controller on your hands. You don't need to have the rest of this. And yes, you don't need to take my word for it. Let's go ahead and just try it out to make sure I'm not lying to you. And just like that, we have virtual reality. We know that we have virtual reality because we have these lightsabers coming off of our hands. Again, we don't have hands until we configure the avatar. But for the time being, we do have these line renders. So we know that they correspond to our controllers. And we know that we can look around as well. So all of a sudden, you see that all we had to do is install the package and then add the Xrtk, add the XR rig, and we're good to go. But that's not good enough, right? Because the next step is actually interacting with our world. How do we locomote around or teleport around? And for that, we are going to hop back to our presentation. And for those who have sat through a presentation of mine in the past, you'll know that at least at one point, I always forget to share. So I'm just going to double check that I still have, in fact, I'm sharing. I am. Fantastic. And let's keep on moving. So teleportation. Well, we know that we're focusing on locomotion right now. Xrtk out of the box comes with really one form of locomotion, and that's teleportation. Within that, you have blink teleportation or free teleportation, which is what we saw. We'll see a little demo here in the construction project. And then you also have anchor teleportation. So blink teleportation or free teleportation refers to your ability to move anywhere throughout the scene. You point to an area, then you can teleport to it. Whereas anchor teleportation refers to pointing at a specific object and then landing on a very particular position on that object. You don't have that freedom or that agency to teleport anywhere. You have to teleport to a very specific point. They also call that destination teleportation for that point, for that matter. So a few more points here. It's easy to, once again, it's easy to set up. And listen, I know that I keep on saying easy or simple, and I certainly don't mean to belittle the complexity of learning Unity. Because as anybody knows, if they've tried to learn Unity, it's a bear. There's a lot to unpack there. But relative to the old systems of locomotion, this is, I mean, dramatically simpler, which is beautiful. So all you have to do is add a teleportation provider. You're going to add that to the XR rig. You're going to add a locomotion system as well. And then to any area to which you'll teleport, you'll add a teleportable area, or excuse me, a teleportation area. And that's it. It's really just 3 steps, basic steps. And then You can add reticles, as you can see here. These blue shiny objects are reticles. You can add those if you want to polish it, but we're only going to configure teleportation. We're not going to worry about any of the polish. So let's go back to our project. And I promise you that it is actually quite easy. Now, setting the expectations a little more, for those who've sat through a presentation before that I've given, I'm working through this relatively quickly, so let me know in the Q&A if you would like me to slow down. I'm happy to do so. All right, so let's go ahead and set up teleportation. Like I said, the first thing we need to check, well, make sure that the ground, we're going to set up the ground right now so we can actually teleport all over the ground, set up box collider. And we're going to make sure that teleportation area is added as a component. And you'll notice the teleportation area, it has a bunch of different parameters that we can configure. We have a colliders list, we have interaction layer mask, we have some events as well. I mean, a really core part of the Xrtk system is how extensible it is through these events. And by the way, we're not going to talk about code. We're not going to talk about extending these events through code either, but know that just through parameters in the inspector, we can configure a bunch of these events so that we can create custom functionality, custom interactions based on certain events like hover or enter. But if we go past those events, you'll also notice a custom reticle parameter. Again, we remember those balls that were on the ground. This is where you can configure it. You drop in a ball to the custom reticle and you're good to go. And then the teleportation provider as well. We'll configure this in just a minute, but then we also configure the teleportation trigger. What exactly is the system waiting for through your controllers that tells it to teleport? That's what they mean by trigger. In this case, we're going to take a look at our Xrtk, but on select exit is one of 4 events, but for all intents and purposes are 2 categories of events that we can call: the selection or the activation. And on select exit or enter, again, we're going to look at this in the Xrtk so you know exactly what this means, or on activation and on deactivation. So that's all we need to do to set up the ground for teleportation, just adding that one component, teleportation area. But we know that we want to be able to move with the Xrtk. So in order to do so, we're going to set up, we're going to add the teleportation provider to the Xrtk. And then notice that it actually calls for the system, this locomotion system as well. And that means that we need to add a locomotion system to the Xrtk. And you can actually leave these parameters blank. When you hit play and everything compiles, it will automatically find this locomotion system and this Xrtk. But if you want to speed up start time, then you can go ahead and just drag in Xrtk. Awesome. And now we are good to go. If we look at our left controller, if we look at XR controller, you'll notice that we have this parameter for select usage and then activate usage. So remember those 2 categories of trigger events, either selection or activation. And this is where we configured it. So if we wanted to use the selection event to start or trigger teleportation, then we can do so with grip. And then if we configured let's go back there actually. I'll need to speak to it indirectly. If we wanted to configure the teleportation or the teleport trigger via activation, then we can use the activation parameter back in the Xrtk. So we're just going to do on select enter as the default. Let's go ahead and hit play. We should be good to go. My controllers. And now, as I hit my grip button, you can see that I'm moving around the pad. So let's think about how this applies to construction or architecture. You're in a meeting with stakeholders. You want to demo your rendered environment. Or perhaps you want them to explore the entire scene. Let's say you're working on a multi-acre construction project. Naturally, it's going to be more efficient to use a high-fidelity virtual reality project than bringing them to the actual site and having them walk around multiple acres. So in this case, you just saw how easy it is to set up teleportation so that you can efficiently move throughout the scene. All right, that's great, but what about Anchor? We mentioned that Anchor teleportation is the other option. So if we duplicate, let's go ahead and duplicate these assets so we can set up another area to which we will teleport. And we can move that a little higher, in this case lower. All right, and let's go ahead and click on that ground one more time. And instead of the teleportation area, let's go ahead and get rid of that component. We're going to add the teleportation anchor. So just type in anchor. You scroll all the way to the bottom, and now let's configure the anchor transform. And the anchor transform by default defaults to its own transform, or the game object's transform. And the reason being is because it just assumes that it's going to, that you'll snap to the center of the area. But if you would like to stay, say, on the corner, let's imagine we want to stay here on the corner, or maybe we wanted to teleport to wherever this hat is. Let's go ahead and we'll move this hat. Again, I just move the hat down, and we're going to use the hat as our anchor point. We'll go ahead and grab the ground. I'm going to hit the lock here so that we can continue to grab the ground, and then we're going to drag in the safety hat. All right, so now when we point and click at this pad, we're going to teleport directly to the safety hat. And once again, you don't need to take my word for it. I'll prove it to you. Notice how when I use my controllers and I point at the ground, it's white. And then when I point anywhere at that platform, let's point at the far right, I go up, and now I'm at the corner. So question well, you may have noticed that I came in diagonal. Why is my entire world diagonal? And I'm going to pause and wait for the chat, see if anybody has an idea. Again, the reason why I come in diagonally is because my hat is diagonal. The rotation of my hat is a bit cattywampus up there. So we can fix the rotation of the hat. And then it will come in more straight. But we don't need to worry about that right now, because what we do need to worry about is interaction. We just learned how to locomote or teleport around the scene. Well, let's get back to the basics, and let's talk about interaction, because again, such an important part of virtual reality is having interaction as well. So the interaction system within Xrtk is a combination of using Unity's physics system, but then also the grabbable architecture. So what we're going to do is we're going to add the rigid body to our target object. We have a few typos there, but rigid body to our target object, and then we're going to add this component called the XR Grab Interactable. We'll add that to the object. As you can see in our original project here, we just had a demo cube, and all we had to do is add that rigid body, make sure there's a collider on there, and then add the XR Grab Interactable, and then we are good to go. Because we also have a collider on our controller, and that collider acts as a trigger. When those two colliders meet, the system knows, Xrtk knows that it's time to grab once you hit the particular button on your controller. So let's go ahead and have a look at just that. Let's set up grab in our project. Let's see, which one was it? I'm going to shut down the second one just so I'm not confused anymore. All right, so what do we want to grab? Well, we can grab paint. Let's go ahead and grab a hard hat. We'll grab a hard hat. We can also grab the goggles. We can grab, I mean, geez, we can grab this wood as well. So, but let's just grab the hard hat. That'll keep things relatively easy. All right, so we don't need this to be a teleportation anchor. Let's go ahead and remove. Oh. Be careful, because remember we hit that lock button, so make sure the lock button is not on. So we'll hit the safety hat, and we want to make sure that a collider is on there. So now we add a collider so that Unity can render this object with the physics system. And how do we know how big that collider is? Well, you can hit this button here and then you can manually configure that collider. So this looks pretty good. I mean, it's good enough for the demo. So we'll go ahead and leave it as default. And what's the second object or the second component? The grab interactable. So grab that second component, pun intended, by the way. Grab the second component, XR grab interactable, and then we are pretty much good to go. We need to grab a rigid body as well. So add a rigid body. Excuse me. So once you add the XR grab interactable, it actually adds the rigid body for you, and it toggles on gravity. So thank you, XRTK. You're so useful. Once again. And now the next step. Let's find our controller. We don't need both controllers. Let's just say we only want to use our right controller for grab. Actually, the crazy part is that we're good to go. We don't need to do a single thing else if we want to use distance grab. So let's go ahead and demonstrate just that. If we want to grab objects from a distance, we can do it now because the grabbable is ready to go. See? And then we can throw the objects and we can grab it from a distance. And again, this is quite handy if we are using XR, say, as a design tool. Again, if we want to move different objects around, let's imagine we're in an interior design space, or just as a sales tool, we know that the more engagement you can generate from the stakeholders and everybody in the room, the more euphoria, the more excitement and optimism. You want the whole team participating. And a very effective way to do that is by creating this or adding this interactable architecture. Great, so that's distance grab, but let's say you want to only grab an object if you're very close. Well, you can do so by removing all of the line renders and the XR Ray interactor, and then add a new component. It's going to be called the direct interactor. The direct interactor means that once your controller directly touches the object, then you can interact with it. And you also need to grab a collider. So let's go ahead, add that sphere collider. Okay, you may be wondering, okay, that's great, but how do we know how big that sphere collider is? Is it 100 miles wide or is it 2 inches long? Who knows what the diameter of that sphere is? So a nice little trick here is to add a sphere. And we can see that out of the gate it defaults to 1 meter, which is way too large, right? So let's go ahead and scale that down. Scale it way down. Cool, now we're gonna have a little snowball hand, but that's quite all right. We can get rid of the sphere collider as well. So you know that the scale, your hand, is going to be 0.05 meters. Now let's go ahead and test. It looks like we're going to have to bend down and get it. There we go. All right, what is going on? Why is it not working? It's not working because we didn't turn on trigger. Make sure that when you do configure the object that this trigger, the sphere collider, is in fact trigger. And now we should be good to go. Let's go ahead. So it doesn't drop down as well, guys. We're going to add a collider here as well, the box collider. The hat was under the table because there was no box collider under it, and it was using gravity. And now it works. We can grab the object, and everybody on the team will be happy. The interior designers will be happy because they can move furniture around. The project managers will be happy because they can stay involved in the project. Your boss might be happy because they're involved as well. Everybody's happy. So now we have interaction. With interaction, we have locomotion as well. Well, you now may ask, okay, that's great, but how do we actually get user interfaces involved? We know that the core of every application revolves around the UI. So how do we build out a UI system? How do we build a menu for our application? Of course, branded for your team. XRTK, once again, makes it simple by just adding a few components. The XR UI input module will be automatically added to the event system once we add an XR canvas. XRTK has its own canvas. It comes pre-configured, and then automatically does the work for you. It configures the event system and the input module. It pretty much does everything for you. So if you don't take my word for it, let's go ahead and once again, we'll give it a try again. This is the demo video on the right. One gotcha here is we just removed the Xrtk interactor from the controller. But if you don't have the Xrtk interactor, you actually can't interact with the canvas. So make sure that the Xrtk interactor is either added back to the controller or you're just using the teleportation controller, which still has the Xrtk interactor. All right. Double check to make sure you guys can still see the project. Looks like you can. Cool. All right, so let's go ahead and create that UI menu. Go down to XR. Normally, the workflow to create UI menus is to stay in UI. So again, you right click in the hierarchy, navigate to UI, and then you can add image, you can add canvas, you can add a scroll bar, slider, anything. But in this case, we just need to add that first canvas, which configures everything for us. So XR, UI canvas. Now we have our canvas. So let's look at the new components. We know that attract device graphic raycaster is automatically added to the canvas, and that keeps track, again, of that XR interactor that's on your controller. But what becomes interesting is when we look at the event system. The event system, classic event system, and then the XR UI input module. That's critical to interact with the modules, or excuse me, the canvas as well. And Xrtk is so great that they even gave us two, which is unnecessary. So thank you, Unity. As generous as that is, we don't need it, so let's go ahead and remove it. XR UI input module, and we are good to go. So let's go ahead and just create a quick UI. We're going to do so by selecting our canvas. Go to UI and then add an image. Let's make sure that the image scales across. And then we're going to add one button. No more, no less. Oops, not text. We want to add a button. I'm adding a Text Mesh Pro button. And if you have experience using Text Mesh Pro, you'll know that you always need to import the Text Mesh Pro library upon using it. A few years ago, Unity acquired Text Mesh Pro. This was a third party, and now it's just a part of the native system. So let's go ahead and keep that in the middle. And we're just going to leave it at that because we just want to demonstrate functionality. We don't need to demonstrate fidelity or anything like that. And you'll notice that it's quite large. So let's go ahead and we'll scale it down. Scale it down and let's make sure that our beautiful UI is big enough and in front, well, not in front of the pad. That should work, just off to the right. So now when we go and hit press, or excuse me, when we press play, we'll be able to interact with this button. Or I should say we should be able to interact with this button. Because inevitably, I may have missed something. And you can see, I'm pointing, you can see where the line render, if we point at the ground, yes, we can still move around. If we point at the hat, we can still grab the hat, distance grab. If we want to go up top, we can still go up top, again with the hat as the anchor point. And if we press the button, we can press the button. All right, so we are good to go in our project. You guys are pretty much XR masters now. Let's go ahead and talk about a few things that we just did. Because there's nothing more frustrating than when somebody just blindly goes through a presentation and doesn't provide any context and then any roadmap for continue to dive deeper. So we don't need to pay attention to the canvas right now. We need to spend all of our time looking at the Xrtk. So again, I mentioned that the Xrtk component is added to this Xrtk game object, right? It's just an empty game object until we start to do something with it. But by automatically adding the room scale Xrtk, again, remember the first step, we get this object automatically configured. And we can adjust a few of the parameters. I mean, we can adjust, we know that the rig base is always gonna be the Xrtk, but we can adjust the camera Y offset. So if we want it to be lower than 1.3 or higher than 1.3, again, right now when you hit play, the camera Y offset is the Y value for the camera offset. So again, if you wanted to be 10, if you wanted the offset to spawn, if you're a giant, you want it to spawn 10 feet or 10 meters in the air, you can set this to 10. And that's pretty much all you need to know in terms of the XR camera rig. Yes, there are a few other parameters here, but you'd never modify them for your own development. But then if we look at the left-hand controller, that is responsible, and the right-hand controller, this XR controller is responsible for all of the inputs, right? So this is where things get a little more interesting in terms of what you can configure and customize. So we have the pose provider. You don't need to worry about the pose provider. Again, it defaults to the controller there. We have specification for right hand versus left hand versus eyes, if you had multiple cameras for multiple eyes, or even the head in this case. Not sure why you would ever want to make your camera or your headset a controller, or at least in my XR career, I haven't experienced a time when you need to. But I'm sure there are some artists and some really creative people who can think of some really unique ways in which you can use your headset as an input. Time-based, for instance, maybe a time-based reticle. Again, the core of input revolves around select usage and activate usage. And you can modify which button on the controller is responsible for the select usage and then the activate usage. This is only relevant when you have those interactions. If you wanted to grab, say, instead of with the grip, but with the trigger, then you can modify to trigger pressed. Oops, that was grip. So now when we hit the trigger, we engage the select usage event. You'll also notice that the UI press usage. Right now, which button can we use to press a UI? And again, we have this event, and we can set the parameter to trigger or grip or a secondary button. If you want to hit A, for instance, you can use joystick as well if you want to be the primary touch stick. And that is pretty much all you need to know in terms of the XR controller. From there, you're good to go. Now, if we were to look at this object that we can interact with, again, the safety hat has this grab interactable on it. And if we open up grab interactable, we have a few more parameters here. And then I'm going to hop back to the presentation. I'm going to wrap up this workshop. So we have the attach transform. If you wanted to specify where in the hat you'd like to grab, you can add a child object and then take that child's transform to designate where you're going to hold onto the hat. So if I only wanted to hold on the hat from the brim, then you can do so with the attach transform. Same with the attach ease in time. Excuse me, the ease in time. That's how much time it takes to snap to your hand. Movement type is kinematic. There's no reason to modify movement type in this case. You have a list of colliders here as well. And you'll notice, by the way, as you continue to explore the package, Unity had done a really great job with their documentation. They provide a ton of tooltips. So if you're ever unsure of what does what, for instance, let's say the list of colliders, we see that a collider is to use for interaction. If empty, we'll use any of the child colliders. So again, any collider that should push the event or trigger the event to grab this hat, in this case, you can add those colliders here. So if you have multiple colliders around the hat, one at the brim, one behind, one under, one in the middle, again, you can add all of those colliders, and if those points are all children points, so you can add all of those children, or children game objects, so you can add all the children, the colliders. Interaction layer mask, this is a more relevant concept for teleportation. The teleportation system and any kind of distance grab system revolves around raycasting. So you're firing invisible lines out from your controller. And if you don't want it to interact for the sake of optimization, if you don't want it to interact with every single object in the scene, then you can specify which layer. And again, this is a physics concept. Unity has a ton of documentation on it, but you can specify which layer the raycast will interact. So again, if you're CPU bound, this becomes very important. I'm just looking through the rest here. Track rotation, track position, throw on detach. Again, you're going to throw. This is a calculation to help you throw an object so it doesn't just kind of fall out of your hand. If you have any velocity attached to it, if you're moving your controller as if you're throwing an object, you have that velocity attached to it, then it can apply the velocity to that object and help you create a more organic feeling throw. We have a throw smoothing curve. Again, these are fine interactions. This is for the interaction designers who really want to fine tune that grabbing interaction. Not relevant for the majority of us. And of course, we have our event system. So let's say we wanted to add a script that changes an object's color. We wanted to make that helmet, instead of yellow, it becomes blue on hover. So as we put our hands over it, and if the colliders interact or overlap, then we can swap the color, and we can do so with this on hover event. We're not going to do any kind of custom code today, primarily because every time we do live coding, something inevitably goes wrong. So we're not going to go down that route. Also, we've pretty much run up on our 45-minute mark here. So we're going to hop back to the presentation. We're going to give you a few bonus activities. So if you are interested in continuing to explore, first of all, feel free to reach out. I'm happy to help at any point in the hackathon. But precise placement and precise movement is very much two features that are important in Xrtk. When I say precise placement, I'm referring to the socket system. So as you put an object down, if you want it to snap to one particular area, you can grab this socket interaction and then add a target transform to that socket component, and then all of a sudden any grabbable object will snap to that position. So I'll leave the slide as reference, but again, I encourage you to continue to explore that. We'll look at a quick demo here. Great, again. Actually, I don't believe this one has a socket in it. Yeah, no socket in this, no problem though. And then rotate set distance, and then use snap. So snapping refers to moving incrementally or rotating incrementally. The default design pattern there is 45 degrees. And that's the industry standard. And in order to do that, to use your joysticks to rotate instead of moving your whole body around 360 degrees, is just adding a snap rotation provider to the Xrtk. That's all you have to do. You do need to specify, actually, you need to specify to that component, you specify which controllers will create that interaction, which controllers will influence that interaction, I should say. So as you say, you use your left controller. If you use your left joystick, that's how you'll rotate around. But again, these are some bonus features that you can dive into. In the meantime, typically I'm joined by my colleague, Andy Jezevar, as Director of Technology at KairosXR. That's why his face is here. But anyways, thank you all for coming. I hope you guys had a few good insights here. I will stick around for a few questions. But until then, good luck in your hackathon. I look forward to seeing what everybody builds.